Okay, so whenever you do a halogen chapter, right, you need to know Sn1 and Sn2. So the clue is that, of course, the first clue is to see the number of molecules, right? So this is a bimolecular. Got two guys, it's called a bimolecular reaction, right? Got only one guy, it's called a unimolecular reaction. So the 1 and 2 refers to the number of molecules, not the number of steps, right? So the lame thing, I don't know why is it like that. I mean, it's just like that. This is one step, but this is two steps. So whenever it's one step, I cannot see slow and fast the word. Right? The moment you see slow and fast, it must be two steps. One step is just slower. Okay? So how does it work? Okay, let me just squeeze it here, right? So because is Sn2, right? So I try to draw in so I must draw in a tetrahedral arrangement, okay? So we try to have that kind of position, right? Okay, no, this one here, right? So this CH3 also came out. So I try to tilt the thing, right? So CH3, right? Yeah. So we try to do it this way because of a reason which I will tell you in a while. Actually, this part, unit also can. This part. Okay, depend on school again, right? I think we make this complicated H and H. So you just draw in this format, and remember delta plus delta minus. So remember delta plus delta minus got be side by side, understand? Because that guy making delta minus or delta plus. That guy the delta minus make the other guy delta plus. So now because I set Cn minus as the nucleophile, so Cn minus, remember this is the arrow. The arrow has to be from the 2 dot and attack in a backside. So another clue is backside attack. There's another video later show you. I'll revise all the different pointers. So this is a backside attack. Why must backside attack? Why cannot front side attack? Or why cannot attack the other side? Why must from the back? See? Why cannot from the front? Okay, repel because there's delta minus, and another thing is that the CR is very big steering hindrance, right? So you got to attack like that, right? Okay, so attack like that because it's Sn2, we draw an arrow, right? And then we draw a box, box. Why must draw a box? And then some school need you to do this, have not? Got this thing not? By right, the last time when I was a student, I need to draw this one also, a minus charge as well as the not equals, right? It indicates what? That two stroke and down is a transition state. The minus because there's a Cn minus, so overall must be minus. Okay, so now, okay, but some school take away this, I don't know why. Okay, but anyway, we just follow, depend on school notes again, double check. So now, take note, this is a dotted line. Why? What's the meaning of a dotted line on the left and dotted line on the right? What's the meaning of this? What's dotted line? What's the dotted line? What does the dotted line stand for? Mean what? In the midst of breaking, in the midst of forming. In the midst of breaking, in the midst of forming, right? Then there's a CH3 on top, right? Then there's a H. So this is some school use the word what? Pentavalent transition state. Transition state is different from intermediate. Later I'll tell you the difference. Or I'll tell you now, there's no such thing like that. Five carbon 4 bond. So this is like an imaginary guy in the midst of going through. It's a one step, right? So it continue, and then after that, now is the other way. The umbrella push it this way. There's an inversion. So can you see all the clues? Okay. Then of course there's a byproduct, the Cl minus. This is the 3 marks. Also difficult. Please understand it because now this A level, a lot of thinking, they might hint to you this part. They won't tell you. So you must know all the clue. Pentavalent, inversion, backside attack. Yeah, something like that. Okay, can? Okay, so this is Sn2. Now, Sn1, how? I feel easier. I mean, depend on you both. You must know both anyway. Delta minus delta plus. Okay, break. So, because it's 2 steps, please put the word slow. On top, don't put anything. Some school need you to go and draw in a trigonal planar way. No choice. If your school no need, some school no need. Because the notes never right. Okay? Okay, so depend on school. So trigonal planar way. So you must understand why Sn1 is preferred. Before I continue, what is the reason? Can you tell me some reasons why Sn1 is preferred for this? For the green one, why I prefer Sn1 than Sn2? You know the reason why. Wait, you can understand? I mean, not understand. You know the reason why? A very good steric hindrance is one key point, right? Steric hindrance, like Matt, there's another key reason. What is it? Okay. Steric hindrance, wow, cannot backside attack, wow, cannot block, wow, benzene there block, that guy block, can blocking. Something is very stable. What? Nothing in there. Huh? Yes. So another clue is that this is a very stable carbocation intermediate. So I say intermediate versus transition state because he's a real guy that I can isolate out. It's a real guy. So why is this stable? Wow, very nice. This one. Come on, I draw that is super good. Right? First of all, there are a few. There are two, right? The CH3 and the CH2, CH3, the two alkyl electron donating. Okay, wait. Because it's electron donating, the plus is bigger or smaller again. Because the alkyl group are electron donating, got two of them compared to the top only one. So the plus is dispersed or intensified. When I got electron donating group. More electron donating group, the plus will become bigger or smaller. This one is an important concept forever. Guessing or understand? You guess or you understand? You must be honest. Okay, guess. Okay, good. Must be honest. Then I tell you why. Wait, you can tell me? Explain. Correct. Okay. Okay, correct. I know you understand. Okay, let me you understand because later on, carboxylic acid got all this problem coming again. So plus means no electron, right? So I got people donating money to me. Is it not so plus? Correct. So must understand because I can. One of my students few years ago, I teach half an hour on this thing. She just cannot get it. Must understand. Later can have a problem. You understand? So plus means got electron, no electron, plus. No electron. So donate good. It helps. So not so plus. So in organic chemistry, they don't like plus, right? Similarly, they don't like minus. That's next few chapters. Okay? And this one even power. Can you tell me why? The plus is even more dispersed. By who? Huh? By who? Why benzene can disperse the charge even further? Because electrons can delocalize. Means, okay, difficult for me to analyze, but I mean, you cannot see like that, but electrons are moving, then some move out. Then the plus become less. So benzene helps. Wow, so this guy's super stable. I will surely like Sn1. Okay, so but how to continue? Can listen, I see yours. Okay, like that, -1 mark A. Very strange. Just like I said like that. Very scary, See, it's like so correct. Then note sometimes they say a bit. Okay, I'll show you. The Cn minus will now come in to attack because, wow, very tempting because got plus, right? Now, because eventually I can visualize that my final guy is a what? 4. So I must draw 2 arrows because eventually it's a racemic mixture because my final product of 4 different groups. You see how when my Cn going, is it 4 different groups? Got CH3, got CH2, CH3, got benzene, got Cn. So I need more space here. I need to draw a dotted line because I need to draw the racemic mixture. Remember not? So okay, I try to follow. Okay lah, no any position is fine. Okay, sorry. So you know racemic mixture must draw the enantiomer. Means dotted line, solid line. I follow the top just now lah. Can see lah. I follow the green guy on top. Then CH2, CH3, and CH3. Same thing. Go and just copy already. Cn, right? CH3. This one benzene ring. This one CH2, CH3. ASN. Means you must know this very well. 50% probability top and bottom. So eventually 50% racemic mixture. Please understand. Means optically inactive. Okay, copy first before I explain more. So nucleophilic sub, can you put the number 3? You need to know this 3 lah. 3 nucleophile. So number 1 is your OH minus, right? Number 2, you see, I simplified so much already. I didn't do my best. It's Cn minus, right? And number 3 is your NH3. All got lone pair one. Only 3 only actually. Not so thick for what? Sometimes I feel. But they teach it properly in the school. Knowing these 3 is just one thing. What are the reagents? Remember or not? So this one, how to produce that is NaOH equals heat. Cn minus, second your exam on Monday, what is it? Cn minus? Huh? Okay, some school write NaCN, some school write KCN. Okay, choose one, not both. Ethanol and heat. You see now. Last one is very irritating. Excess concentrated ammonia. Don't ammonia first. One more reagent first. What? Excess concentrated alcoholic ammonia. What? Heat in sealed tube. Only 3, please remember, right? These are the 3, but exam can ask you other things. But at least you know these 3 first, then exam you apply other things. Correct or not? If the ammonia not in excess, what thing happen? If the ammonia not in excess, what happen? That very irritating thing. Hopefully don't come up for a test for now. I know I'm still got to learn. Poly what? Poly what? If the ammonia not in excess, poly what will appear? Polyalkylation will take place. Means what? See, I don't know if I'm teaching that. It's too long, but never mind, no choice. I say again. Okay. So let's say just a normal one first, like that. So a perfect situation, ammonia coming to attack. Okay, like just anyhow, right? So ammonia coming to attack, what you get? Cr, okay, 1H will drop out. Plus Cl minus, correct? So if ammonia excess, then this thing one sub only, but ammonia not in excess, what happen? This guy now attack. Because now this guy excess, ammonia not excess means this guy excess. Then what happen? What happen? Practice drawing until you finish entire thing. Pause. HCl, not Cl minus, just like careless, right? So HCl, then now can you figure out when the blue, that means the product now attack, they act as a NH3 because there's no more NH3, NH3 limiting reagent. What is the new product? Try to draw. Okay. So you must know that the next product will be the N now connect to 2 big chunk, right? 2 big chunk. So okay, see now I can use the color, right? Wait, I should use the color. So the N here connect to 2 big chunk. Okay, C R H H. Okay, but because he connect to he attack, I want to say he attack, right? So it hit the C. Okay, then there's still the H. Okay, like just use blue again. So there's still the H, and then lone pair. Right? Then of course, this guy now can attack one more time. So later on, you must draw out the third one. Okay, so no, very bad. I should use the color code, right? Then you understand fully, right? So N C R H H, right? Then what happened here? C R H H. Then H. Ayo, then red again. Ayo, because the top guy is red, right? So another red guy coming. Sorry, no more H already. Every time one attack, his CL drop out. R H H. 18, understand? Right? Then, so sad. Very tedious one, but no choice, can come up for exam. Then a lot of people will skip or don't care. A lot of friends don't know, and I mean like, or lazy to figure out, or lazy to draw. Right? Then after that, you must know that the last one is 4 bond, so it's plus and Cl minus. Okay, I'll tell you the hints. How will they hint you to draw this? Because they won't say, hello, please do that. Okay, so C, H, H, R, and also C, R, H, H, and Cl minus. So this is called a quarter. Yeah, this part I just cannot spell. Ammonium salt. Is it soluble in water? Very soluble in water. Why? This is a hint. They say, oh, the final product is suddenly very soluble in water. Why? The quaternary ammonium salt is very soluble in water. Why? Why? Explain why. They can ask you explain also. Chemical bonding concept. Whenever it's an ionic compound, what they form with water? Strong. Right? Whenever ionic compound is plus minus ionic now. Huh? Yeah, strong ion dipole interactions are formed with water, right? So releases sufficient energy to overcome the hydrogen bonding water and the ionic bonds in this guy. Yeah. So whenever it's an ionic compound, there are ions, it is very soluble in water. So this is another hint, right? This is another hint to tell you that ionic compound is formed. Understand? Okay, so you remember whenever it's a RCl, I get this. What's the condition? Wait, again, what's the condition? Very good. Right? KCN, ethanol, and heat. You get RCN. But exam will never stop here, right? So exam will continue to ask you to do this. So this is acidic hydrolysis. Right? So the first one is called acidic hydrolysis using dilute what? Two acid can use heat. HCl? No, that one cannot. It's too oxidizing. That one is too reactive. Okay? Right? So I don't need to ask you why, but just learn only these two strong acid can. Okay, I also can use basic hydrolysis. Right, basic hydrolysis will be dilute NaOH heat. Then you get RCOO minus N plus. These two link together, right? It's just acid or base. The N gone, the CN gone, COH or COO minus. Okay, so remember COH or COO minus. The last part is called reduction. After you reduce this guy, I'm like adding 4 H's. Okay, can you see or not? As though this is new, this is new, this is new, this is new. This is how I can teach you a little bit. Because the original guy actually is a triple bond, just like that. Once you have the impression that I'm adding 4 H's, right? You will know that, I don't know if it helps your brain, but anyway, LiAlH4 in dry ether room temperature. This is one possibility, okay? And the second alternative is your H2 nickel catalyst heat. Okay, of course, that will not escape. Of course, if it's platinum or palladium, then no need heat. So whenever it's a reduction, you need to think of reducing agent. And this guy, number 1, is the strongest reducing agent, can only reduce carboxylic acid, but here also can reduce iron. And the H2 nickel catalyst found in which chapter? H2 nickel catalyst is found in H2 nickel catalyst. H2 nickel catalyst is found in our kin chapter, right? Then it is platinum, palladium, stronger catalyst. Okay, so now let's analyze the two reducing agent, right? This guy can reduce CrCOH and many more. Okay, can reduce everything except alkenes. So if you look at this pattern, this guy is a stronger reducing agent. This is weaker reducing agent. Okay, in the periodic table, they are on top below the B and H, AL, sorry. So our focus is actually your ALH4 minus and your BH4 minus. That's the focus. So these two are what we are studying. Now, in the periodic table, B on top, AL below, group 13. Now you got to think, this is A-level question, keep on asking. Then a lot of schools keep on asking already after that year, I don't know, maybe a few years ago. Why is that guy stronger than that guy? Why is ALH4 minus a stronger reducing agent than BH4 minus? What do you think? Have the impression, the A-level question, so you better know. Maybe it's in a small part of the notes. So you need to know that ALH versus BH. Whose bond length is longer? Because I'm breaking away the ALH bond and the BH bond to supply hydrogen to the other guy. So which bond length is longer? Again, the period table at BAL, B and AL is below. So whose bond length is longer, or which bond is easier to break? Wait, whose bond length longer? No, AL, because AL is, okay, I'll show you how to analyze bond length, right? Who is larger? AL, right? So AL is larger to the H, right? Right? Can you see now? B is smaller to the H, right? So can you see that the bond length here is shorter and is longer? Right? The larger atomic radius will give you a longer bond length. Means, okay, so to say properly, AL has a larger atomic radius than B, because AL lower, right? So orbital overlap between AL and H is more or less effective. Compared to B and H, AL and H more or less effective orbital overlap. Less, because the bond length longer, right? So less effective, right? Orbital overlap between AL and H is less effective than B and H. Therefore, longer ALH bond length than BH. Weaker ALH bond energy. Easier to break. Therefore, stronger reducing agent. Therefore, ALLI. Yeah. Therefore, LiAlH4 is a stronger reducing agent. Reason number 1, right? After this, we can break. So this is reason number 1. So reason number 2, now ALH and BH, okay, so I try to move up. ALH and BH. you need to know that this is the delta minus, this is the delta minus, this is the delta plus, this is the delta plus. Can you tell me who is more delta, which bond is more polar? That means who got greater difference in electronegativity? ALH and BH, both is delta, but who has a greater difference, making the bond more polar, more easily broken than which one? Periodic table again, B on top, AL below. So who got greater difference in electronegativity? Okay, think slowly, B on top, AL below. Or again, who got a greater difference in electronegativity? This is the focus lah, using atomic structure concept. You say ALH got greater difference in electronegativity. Very good. Here got a greater difference in electronegativity because B is more electronegative than AL. Or AL is more electropositive than B. Up to you. It's the same thing. Choose one. Yeah, this is the explanation why. No need to explain that. That's atomic structure. So this is a real explanation to giving you a greater difference in electronegativity, leading to more polar ALH bond. Therefore, more easily broken. This is another reason. Understand? So I can supply my H minus better. Okay, I think I should rephrase. Don't say supply H, supply H minus. Right? The key idea of the two jokers is to supply hydride ion, H minus. Okay, come. So number 3, right, is something that we know is nucleophilic sub, but remember, naturally when I see nucleophilic sub, you need to decide whether is it what? Again, whenever they give you a question on nucleophilic sub, you must decide whether is it correct, right? It's always you need to go and decide. So for this question, is it Sn1, Sn2? Yeah. Very good. Why? Very good, right? So intermediate only belongs to Sn1. Sn2, that joker is called transition state. Right? And this graph indicates 2 steps somehow. So many clues, okay, so many clues, right, to analyze Sn1. So statement number 1, is it correct? Statement number 1. So now I know, so I just focus here, right? So I still focus here. So now it's a Sn1, very good. Statement number 1, is it correct? No. First of all, so many problems, right? The problem is that the 5-member ring is actually transition state, right? And it shouldn't happen in Sn1. Remember just like I told you, right? So 1 is out here. So straight away, wrong, can see not fast. Then when I look at this, right? When I look at this, you know what happened? Wow, I saw 3, right? So I don't want to read 3. I know 3 is correct. I'll teach you lah, of course. Right? So now my job is look to and for must strategize this way, practice until you get it right. Wow, Sn1. Wow, 2 correct. See straight away fast. Less than 1 minute. But I forgot I can teach you why the rest wrong. Okay, so the answer is C. C, 2 and 3 correct. So first of all, Sn1, yeah, overall 1, remember, rate equals to K, right? Right? You know why 1 or not? Kinetics concept, rate equals to KRX, because Sn1 only got 1 guy. If it's Sn2, it should be overall order 2, right? Overall order 2 when it's 1, when Rx and O is minus, right? Then it's 2. Okay, this is a bit weird lah. Removal of that guy does not affect the yield or reaction. Ayo, so weird. I feel this number 3 is a very weird statement, but what are they testing? Which chapter? Not organic, What are they testing for number 3? Which chapter are they testing? That removing something, adding something affect yield. Which chapter is that? In JC1. Sorry, E. Equilibrium. So they're analyzing LCP, right? Use the principle, right? Left, right. So this idea is that I see is a single arrow, so need to talk does not affect you. If it's a double arrow, then affect you. Okay. So I say again, affecting you is about LCP, must be reversible, but the question is a single arrow. Therefore, but very weird the teacher, I think the way they said this is funny, a bit off guard, caught me off guard also. If you understand. So means what? If it's reversible, okay, if it's reversible, if, not this question, but if it's reversible, if I remove what? This one, right? If I remove this, does it increase or decrease U? Say again? Increase. If I remove that, increase or decrease? Shift left or shift right? Again, if I remove the one I circle, position equilibrium, shift left or right? Yes, so it increase U again. If I know there's just no link to this question. Okay? Last one, increasing concentration of hydroxide and reduce time. No, because the rate equation has no hydroxide ion, so it doesn't affect the rate, understand? Take note, this will only be true if it's Sn2, when hydroxide ion is part of the rate equation. You can understand? Yeah, so see. You can understand? If it's Sn2, hydroxide ion is there, right? If it's Sn2, it's rate equals to KRX, right? And hydroxide, right? Then it affects the rate, because you put more rate means reduce time, right? Higher rate means less time, but this is not even Sn2, so nothing. Okay, let's go. Okay, so once a while there's some weird thing which the A-level test these days, right? Some random kind of name there, right? So we just analyze whatever we know, fair enough. So let's check one by one. Nucleophilic sub have or not? Okay. Is there nucleophilic sub? Where? Which one? Okay, this is the first step, this is the second step, this is the third step, this is the fourth step. Say again. Yes. Okay, see third step. Right, nucleophilic sub, right? Where the OH minus, where does it Sn1 and Sn2? I don't care. Substitute. Okay, my head very pain. 1 second. Yeah, very weird the positioning. Can you see now? Attack this guy and fly off. You can understand? Okay, so this is the chapter of the halogen, right? So the new sub have. Electrophilic sub have or not? Good. Step what? This is a little bit in the text. I text you that day. But, so what is it? Which one? Step 1, 2, or 3 or 4? Cannot be 3 anymore. 3 you say. Nope. Electrophilic sub which chapter? Nope. That's electrophilic add. Alkene is add in. Arene. So step number 2. Correct? Because the arene, the benzene ring is affected. The benzene ring sub away the H. Understand? Sub away H, so it's electrophilic sub. Then so must link. So you know what's the link or not? So your idea in your head, oh, this one RX, oh, this one arene. Link there lah. And last one, elimination step what? Yeah, step 4. A bit weird because by right is your normally you should remove HCl1 or H2O. Yeah, this is very tough. So this is really application. Chemistry sucks. Form double bond. Elimination is always form double bond. So yeah, I cannot say CC now. I trapped myself, right? Form double bond. Oh, but like this is application. So this chemistry a bit weird sometimes, right? Normally we form a CC double bond. This one form a CO. So I'm taking out HCl, right? You see not? So I'm taking out where? The pen, we got add. Step 4. Minus. Not add. Minus, not add. Minus. Oh, yeah, I actually don't know. Weird. Okay. So it's very bad one. I tell you, see, very difficult. questions, right? It's like that. A level maybe 1 or 2 like that. But prelim, right? Can set very tough like that. Practice, I think. We try to practice a lot. Then no choice. Okay, let's proceed. No choice, I got to draw. Hopefully you all draw. If not, I cannot see it. From that, right, 1 chloropropane, right? So propane is 3. 1 chloro is, there's a Cl here, right? Or left or right, no issue. 2 methyl propanoic acid. What is 2 methyl propanoic acid? So propanoic acid, 2 methyl. You see? Count the position from the carboxylic acid. Okay lah. So that's all. Just like that. First of all, I spot something. What did I spot? Again, I spot something fast. No, I know it's there, but no. There's something whenever I do question, I know what that one means, that one. From the left to the right, there's something very prominent. No, okay, that's also prominent, but not that prominent. Okay, wait, can I have a? Wait, my whole thing is wrong. Wrong. Okay, be careful. Finding opposite way, then I don't think got answer lah. No, got No, because I thought they just eliminate the options inside. Okay, wait, everybody. Whenever you do Rx and carbonyl, I taught you that. Wow, one more carbon, more step up. Wow, this one I better hurry up. Step up reaction. What step up? A step reaction only in the chapter of Rx and carbonyl, which I haven't taught you carbonyl. So our focus is Rx. This chapter is Rx, right? You know I mean in the exam, you must go and spot that. So straight away, I must involve my ethanolic KCN, right? Heat. Okay, so A is not because you know why not? Aqueous NaCN trace, that one is carbonyl. This part is the carbonyl, which I haven't taught you, so don't. Wow, so carbonyl coming, you very stressed. Never mind first, don't bother. Ethanolic KCN makes sense? Wow, so many steps, wait. Wow, sucks. Okay, we try one by one. Okay, so let's say I try B first, right? Ethanolic KCN, what happens? C, then CN. Then wrong, because after that, this guy will become C, CN, and COOH, right? You see now, remember now, acidic hydrolysis with your dilute Cl. You see now, B, I'm doing B now, right? I substitute the Cl, put the CN becomes COOH, right? Okay. Hold on, I mean B is wrong, and B is wrong. Because B got no methyl group, it's a straight chain. This one is a like that, and one guy comes down, this is straight, right? Okay, so I see the rest out. Okay. Next one, I try I just try different. I try C, right? So it's a C. These are good. I practice a lot. Aqueous KOH. So OH. Gaseous HCl. What are we talking about? What's gaseous HCl? What is gaseous HCl? So funny, No lah, no link. I don't understand what's the gaseous HCl one. Feels like it's the last one, right? Last one wrong, then I also don't know if I see it again. Okay, we try the last one, can? Yeah, so we try the last one. I don't know other colors. Okay, let's try the last one. So, ethanolic KOH, do what? Oh, nice. Eliminate, right? HCl. Now, ethanolic KOH is to eliminate HCl or HX. Gaseous HBr makes sense. So, Markovnikov. Take it, answer. Markovnikov, add the H because the guy goes even to the carbonate more H. Markovnikov product. Then ethanolic KCN. Wow, nice. That makes sense. Ethanolic KCN, C. The side guy there. Then acidic hydrolysis, C. COOH. Oh, nice. This is my answer, right? This is the same, right? It's just that the CH3 now at the side, right? Must know, This CH3 is the same as this CH3. It's the same guy. So answer is D. Markovnikov means focus on this guy, right? HBr, delta plus, delta minus, this double bond will attack. So the H enters to the carbon with more H. You know what's the meaning of carbon with more H? This guy got one H, this guy got two H, this guy only one H. Because like that it will form the more stable carbocation ion. That's the reason, but the shortcut is add the first guy that entered to the carbon with more H. Wait, any question again? Must check through first. Okay, understand? Okay, important understand. And they always put D, right? So I will just run through and like do so much work. Second which one? Last one. WH2SO4. WH2SO4 is the acidic hydrolysis. Remember today I teach you one CN. Listen. Must practice. So actually today I help you this. You can go practice structure A. Halogen and counted. You understand? Right? It's counted A. Must just practice. You'll be better when it's like that. That's what my teacher told me. I say don't bullshit, but really work. Okay, can? Last one. Are you ready? What's it called? Which of the following statement on nucleophilic sub of this? So die must go and draw again. No choice, must draw one. No I power. Even though obvious, just draw it out. Very fast one. 3 methyl. 3 methyl, 3 bromo. I don't know why today I like to start from the right one. No issue, the same. Wait, sodium hydroxide. So OH minus will start to attack. Can see now. So after attack, what happened? Okay, the product has a chiral center. Got chiral center or not? Have because I sub here, I put the OH here. Chiral, not answered, not true. Can you understand? The intermediate is a carbocation ion. True or not? Yeah, that's why not so good a question, but never mind. I know what I'm trying to test. Okay, sorry. Is it Sn1 or Sn2? They will favor Sn1 or Sn2 here. Which one? Eden? Good, Sn1. But this is a very bad question. Recent years, because the school what they teach you all tertiary RX Sn1. A lot of electron donating group there. That's like you need to think yourself lah. No choice lah. I mean, yeah lah, no choice. So, yeah lah, true what? Optically inactive mixture, correct? True. See what I told you just now, right? Hopefully D lah. The OH minus nucleophile attacks just as Br leave. No lah. This I talk about Sn2 wrong. So I just
you ask for why something undergoes like Sn1 or Sn2. Do you talk about the steric hindrance or the
factors? Steric hindrance as well as carbocation ion more stable. Which is what I thought. Yeah, it's just that. You understand? Yeah,